All right, so this talk is, crap, I forgot about the title. I didn't put the title on the slide. So it is REST. So even with more sleep, it doesn't matter. This talk is, we're going to write a REST API server, Node.js server, for a Sencha front end. Okay, so we're going to write this back end. We're going to start with a blank file, and then I'm going to build the server in front of you. I've pre-typed a lot of it, so you won't see me typing. But I'm not going to explain every line, but I'm going to try and give you the major parts of it. Okay, and then you can go home and kind of see what all the parts do. Okay, so I was on the Sencha training staff from 2012 to 2013, so about a year and a half, and now I just do my own thing. Actually, right now, my current gig is I work for a huge Wall Street bank that I write Sencha code for them. It's actually illegal for me to tell you which one it is. Their lawyers told me not to say anything, okay? But if you go to my LinkedIn page, you'll know who it is. Okay. And one of my, it's not really my hobby, but one of the things I've done, my bread and butter for the last, since 1998, I just write web servers from scratch, okay? The reason why I did that is because in 1998, there were no web servers, right? ASP.NET hadn't been done. You had like Perl CGIs, which were awful. So I wrote a web server pretty much from scratch in C++, and it took a lot longer than an hour. And that was for IS, okay? And then in 2004, ASP.NET 1.1 was out, so I rewrote the C++ in C#. And my hand is shaking. I haven't done this in a while. I used to do this all the time for training, but so I did it for C#, and what I did was I took all the ASP.NET stuff and I kind of threw it away, and I overrode the render function and wrote it from scratch, okay? So, and then I'm in the process, almost done with a new web server, okay? And actually, these web servers are for a game site that I've been running since 1998, okay? Turn-based game site. So, and it's still out there. And I'm not telling you which one it is because it looks really bad, but people are still on it, okay? All right, so this talk is about, we're going to talk about web servers at a very low level. In fact, you may never, it's possible you may never have seen stuff like this, but hopefully you have, okay? And then once we understand how web servers actually work, we're going to write our own REST API. It's not, it's not specific to REST, okay? But we're just going to attack REST because that's, I don't know, that's what people want, okay? And then we have a front end to access it, and the sample code is available in the GitHub repo, which if you missed the link, I'll have it again at the end of the talk, okay? All right, why are we doing this, okay? And remember, if you were here for that YouTube comment, it's like, don't watch this shit, not my words, okay? Just use Express.js, and that's a you should do that. If you're going to do a real production server, you should use Express.js, so why are we writing something from scratch, okay? And the reason why is because we want to know the theory. We want to know what's going on underneath Express, okay? Because if you put Express in and you get it into problems, you're going to have to know how to debug Express. And the reason, and this is not just something good to know, okay? There is a blog from Netflix, okay, and they use Express.js. They use Node.js for some of their servers, okay, and they ran into problems, okay. They were seeing that the longer their Node.js servers ran, the slower it got, and they were wondering what the heck is going on. It took them a while. This is a great blog post, by the way. If you want to do node debugging, they go into great detail. Just Google Netflix Express debugging, and you'll see it, okay? And you can see they found they finally found what the problem was. It was in their code, but it was in their code in sort of, how it interacted with Express, okay? That they didn't quite understand. It wasn't anyone's fault. It wasn't a bug in Express, but it was just sort of their slight misunderstanding in how things worked, okay? So you're going to have to know this stuff eventually, okay? Don't use it in production. You should use Express because somebody's written all the code for you, okay? But you still need to know how it works. So that's the point of this talk, okay? All right. So it is theoretical. Don't use this for production because there's no error checking. So if you put this out on the internet, I guarantee you in about 5 minutes it's probably going to get hacked, okay? So yeah, use what's out there, okay? And we've got Express.js, which are node modules. We've got Connect.js, which is kind of Express Lite. It's actually provided by Sencha Labs. And there's a thing called RESTify in case you want a REST API, okay? So if you don't want to know the theory, I told this last time, people actually left. If you don't want to know the theory, this slide will tell you everything to get a node kind of REST API node server working. Okay. Good. Nobody's leaving, so I'm glad. All right, and I have this slide because I sometimes give this talk at other places. So why REST? You're here at the end of the Sencha-con, so you know Sencha's a single-page application. It has all the logic in it, all the display, and the rest serves nothing but data. Okay? So that's what, you used to be, remember, we would serve all the HTML. We don't do that. So the rest just serves the data, and then all the UI is already loaded in a Sencha app. Okay? So that's why REST. All right. So we're going to go into HTTP, very low level. We're going to write a REST server, and then we're going to call the REST API from a very simple Sencha front end. Okay. Okay. Any questions at this point? We haven't really covered anything. All right. Cool. All right. So what's HTTP? It's what it's what we use to transfer data. You guys all know this. Port 80. Okay. So let's take a look at how HTTP actually works. Okay. So we're going to go, let's see, I'm going to talk to Google, okay, on port 80. I'm going to use Telnet. Who's used Telnet in the past? Right. Wow. Excellent. All right. So what we're doing, what Telnet does is, we're just going to send it commands. So we're actually talking to Google, and Google says, all right, let's start talking, okay? So I'm going to do get slash, that's all I'm going to do, and then Google comes back and gives us the data, okay? So it's text-based, right? And if you do a get slash, okay, you are using HTTP 1.0, okay? And then it sends back the date and some headers and then the information, okay? So that is HTTPS. If you want HTTP 1.1, I'm sorry, yeah, 1.1, whoops, that's a ping. Telnet, where is this? Here it is. Okay. Then you have to do get slash HTTP 1.1, and then when you hit enter, nothing happens. You have to hit another enter because, okay, and then it doesn't even close the connection. You have to close it yourself. Okay. So let's take a look at what it sends back. Come on. Okay. So you say, I want to use HTTP 1.1, and it says, okay, I'm going to send you HTTP 1.1. This is actually what comes back. If you've never seen this, this is what comes back to your browser. Okay? It's all text. You could write your own browser by parsing the headers, and then when it comes down here, here's your doc type HTML, and you just parse that, and you have yourself a browser. Okay? So it's all text. There's nothing mysterious. Okay? The images are all sent in text, right? They're UU encoded, and they're in text. Okay? You guys probably know this. Right? Why am I going through this? Because if you're going to write a web server, you need to know how things are going back and forth, right? I mean, that's what we're going to do. We're going to write a web server and listen to like the raw communications going back and forth. Okay, so that's why I'm covering HTTP. All right, and then if you want to post data, okay, and we're going to do this in for Google again. We're going to post data to the Google homepage, okay, HTTP 1.1, okay, and you need to set a content length, okay, and we're going to do content length 9, and then why don't we just send a user agent, and this is Patrick Chu at Sencha-con, okay, so somewhere on Google servers is going to be this user agent. They're going to be like, what is this? And then we're just going to send a hello world. Now notice when I hit 2 enters, right, it doesn't immediately send back something because we gave a content length of 9, right? And we're going to send it a content length of 9, which is this, oops, it's actually 11. So let's hello world 6, 9, okay? Well, that's kind of stupid. Then that'll really screw up the Google people, all right? Okay? And then we hit enter because we're trying to post to the Google homepage, okay? And Google says, method not allowed, okay? And it says 405, that's an error, by the way, okay? And the request method post is inappropriate for the URL /. That's all we know. Okay? So if you tried to post something to the Google homepage, this is what you get. Okay? All right. Great. So we just went through the demo, HTTP 1.1. All right. Let's go to REST. Okay? You may know what is REST. Well, it uses verbs. What are verbs? I don't know. But it uses verbs to trigger CRUD events, right? CRUD is create, read, update, delete. These are the 4 main operations for a database, right? And they're mapped to these verbs, okay? You saw me do get and post, right? But we have 2 other verbs called put and delete, okay? All right, and then there is sort of a URL format. Again, this is not like strict REST, so again, you know, for the next YouTube video, you guys can flame me as well, you know, whatever, keep it going. But you do a get, and if you do a table name without a record ID, then you load all the rows in the table. If you give a sort of an index, it'll just give you that, okay? Create is a post, okay? And then the data that you want to post is actually in the body, right? And you saw we did that with the Google thing. And put, same thing, we're going to update it. And then delete, we actually give the ID of the row that we want to delete, okay? These are HTTP verbs, okay? What does that mean? So yeah, so let's take a look and let's go back to Google, okay? And you saw we tried to post something, okay? And it said it didn't like that, okay? So let's do this again. And then let's do, let's try to delete the Google homepage and see what happens, okay? Okay. So it says I want to delete the Google homepage, okay? And then, well, it says, again, delete is inappropriate. That's all we know. Don't try this, okay? So, you know, we're just sending it text, and it's just parsing that text, and it's like, look, I'm not going to do this. In fact, it says, over here, where is this? It's supposed to say accepted protocol. Oh, they changed. I think they changed their thing since last week. All right. So anyway, all right. So and then if you want to see what this thing looks like, crap. You know what? I'm not going to do that. But I had that page loaded, and we saw, whoops, what that looked like. Okay. So that's a verb. And like, you know, with that verb, those verbs are just defined in RFC. I forget what the number is, but the protocol for HTTP, we have these verbs that we're going to use, okay? But what's a verb? It's really just text that we're sending over, right? So we can actually Uh-oh. That's not good. We can send over any verb we want. I mean, nobody says we can't send over just garbage, right? So again, I can just say call Saul / and then HTTP, which is totally false, right? It's not a recognized verb, and then it comes back and it says the method is inappropriate. Okay? But if you want to write a web server that listens to other verbs, the verb is just like the first thing. Okay? So there's nothing special about the verbs. It's just text, but it's sort of text that we've all agreed on for HTTP to use for our REST server. Okay? And then the server knows how to parse that. Okay? So that's a brief overview of HTTP. All right. So that's what that is, and you have to use 1.1 because 1.0, these are the only verbs that are defined for 1.0. The 1.1 verbs, 1.1 defined a few more, okay, so you have to use 1.1. Again, that's just the protocol, right? All right, so let's build a simple web server, okay? So I'm going to start from okay, good. I'm going to start from a blank file. So I was working on this earlier. We have a blank file, and this is the server that we're going to use. Okay. So I'm typing this in, and you know what? Let's go through the slides, and then we'll look at this. All right. So to create a server in Node.js is pretty simple. Okay. You do this HTTP require. Those are usually modules, but HTTP is a built-in module in Node.js. Okay. You do create server. You give it the callback, the callback that's going to handle all the events, okay? And then .listen, and then you give it the port number that you want it to listen on. That's it. If you do this, you have a server running in Node.js. It's that simple, okay? And then I just give it to say, what port number you're running on, okay? All right, let's look at the on request, this callback, okay? Let's see what's going on here. Okay, there are several events that you need to listen to, but the two main ones are data. Okay, and the data is if there's a body, if there's a post or a put, if there's data coming in the body. Okay, it comes in chunks, so you need to, whenever something's going on, you need to sort of add it to whatever has come before. It won't all come in one chunk. And then at the end, okay, here, this means all the data has been transferred, okay, and then we're just going to output hello world. It's not really a useful server, but we're just going to kind of get this working and see what's going on, okay. So yeah, there's the data and the end. Okay, great. So let's take a look at this. So we have our code here, and this is basically the code in the slide. Okay, we have HTTP require. Okay, we've got a little bit more. We've got hello world, and then what we're doing is we're outputting the method and then whatever data we've posted. Okay, so let's run this server. Node talk.js. Okay, it's listening on port 3000. Okay. And then I've got these scripts that will kind of go against it. So curl, instead of typing in telnet, curl will do a whole bunch of stuff. Here's the help, okay? But V means verbose, so we're going to see the communication going back and forth, okay? So we're going to go against localhost 3000, okay? And then we're going to see the stuff going back and forth. So it sends a user agent. Remember, you could type this just like I did, right? So what curl's doing is it's just sending text to the server, and then the server is just sending text back to the screen, okay? So it says, all right, and then the server, I have to come down here, all right. So the arrows going this way is what curl's sending to the server, and the arrows going this way is what's coming back from the server, okay, if you're looking at curl, okay. So curl says, okay, got a 200, okay, and it sends these headers, and then we get hello world. Can you see in the back? It says method get, you know what? Whoa. Oh. My wife said, buy some tight jeans, you'll look better. So method get, and we didn't send any post data because it's a get, okay, and then we closed it, okay. So let's see what happens when we do a post, okay. And here's the command that we send. So in curl, when you want to post some data, there's this -d, okay, and it's some data, okay, and then curl knows enough to send the content length over, and then we get this back, okay, and then we have post some data. Now let's take I mean, we have a server that's actually running, right, because here, this is what's going on. We have this method that we're adding, and then the body string, right, remember, any data that's coming in, it's being added to this variable called body string, okay, and then it's creating this string, and it just sends it out, okay, so there's your server. All right. So now we've got a server running. It's kind of boring because all it does is just push back what we send it. So we have to make it a little bit more useful, right? So let's go ahead and do that. Through the miracle of code snippets, I can just throw in some code. Okay. So we're going to, actually I'm not going to go through this, but we're just going to add a few more headers. Okay, we're going to do a content close, and we're going to send back the length that we're sending back. Okay, that's not really that useful. All right, and then let's just go ahead and do this anyway. So now, oh, I have to restart the server. Okay. So now when we do this, we see. Oh, I forgot to save it again. Okay. Okay, save it, then restart the server, and then let's do this again, and then you can see we have a few more headers, okay? And there's a difference now. It says closing connection. Before, it didn't. Before, like, it actually left this connection open because we didn't have that header to close the connection, okay? So these headers, I mean, you can see, you know, curl is a client. It's actually taking action depending on what headers are coming back, right? I mean, that's what you want with a browser, right? The thing that's important about this is we have to put this in. There's this thing called cores. We're going to be running our client and our server on different ports, and it's treated as different domains. And you're not supposed to get data from a domain that's different than your own, unless you configure your server, okay? I once tried to read like how to do this on Apache, and I was totally lost. Like it was, I don't know, it's possible, but there's this kind of this very long article on how to do this, how to implement cores on Apache, but really this header is all you have to set, okay? So you don't have to, well, you're writing the server, so you don't have to configure it. Okay, so that's why we put those headers in. All right, let's see what's next. Okay, so we want to take action based on, right, different URLs should do different things in our server. Well, that makes sense. Okay, so we're putting in, what we're doing is we're splitting the URL by slashes, and that will give us the table name and the record ID. Okay, so let's take a look at this. Let's restart the server. Okay, and then let's see. Let's do a list. Okay, so what we're doing is this is the URL that we're using. Okay, so we have our server, and Sencha-con is the table name. Remember in the REST slide, if you just give it the name of the table with nothing else, it sends back the contents of that table, all the rows. Okay? So this is kind of where we're trying to get to. okay? In order to do that, we have to know we're trying to parse the URL. So this is what this does, okay? So here's our path, okay? So it knows what path you sent it, and then it's splitting by that slash. So here's the table name. We don't have anything after it. If we send something after it, okay, here's the URL. Sencha-con is the table. Number 1 is the index to the row. And if we split that, we get the table name is Sencha-con, and the record ID is 1. Let's look at the code. And right there, that's where we are. So this table name variable has our table name after we do all this parse stuff. Actually, it just says take the second element of the array when we split it, set that to table name, and then set that to record ID. You can sort of see, if you were a hacker, how, totally like brittle code, okay? But I just wanted to kind of give the minimum code possible, right? So we actually have parsed our URL, okay? And we know the method, right? Like the method is out here, right? So whatever we send as the method, it's going to put out. So we have the elements for a REST API server, right? We know the method, and we know the URL, and we'll know the record ID whenever we need it. Okay. Right. Any questions so far? Okay. Pretty straightforward, right? I mean, it's easy. Writing a REST API server from scratch, it's easy. All right. So once we have this information, okay, we want to call a function that actually does all the REST operations, right? So let's see. This, you know what? I'm just going to put the code in, and then I'm going to run it, and then I'm going to explain it, okay? So here's the code that I just put in, okay? And there is a database behind it. The database, excuse me. The database is SQLite, okay? But here in the DB, this is sort of importing a module, node module, but it's in the same directory, okay? If it's the same directory, what it does is just looks for a JS file, okay? So here's a JS file. I'm sorry, this is in CoffeeScript because I write mostly in CoffeeScript. And I use this sort of front end, this ORM called SQLize, okay? You can use SQLize as a front end to MySQL, Postgres, SQLite, there may be some others, okay? I'm using SQLite because when you download the code from GitHub, it has the database file embedded in it. So you could just type in node whatever, and it'll just run, and the database is already on your machine. You don't have to set up MySQL or anything like that, okay? So that's why I use SQLite. It's very handy, okay? So we have a database, and let's just run this. I mean, I'll explain it, but let's just run it. So let's try to list the table. Oh, I need to restart the server, okay? And here it is. So here's the data. Here's the JSON, right? And success true. You may notice this is very Sencha specific, right? They want success true. They want the total, the number of rows, and then the data is in an array. So here's all the columns, and this is ready to. If you have a model in front, and you set the proxy, it will parse that. It's ready to be parsed. Okay. So let's see how that works. Okay, and I realize this is kind of some code. Here's, you know what? So here's the call to the to this function, this thing called REST function that handles everything. But I'm just show you the call, the method call. We give it the method, table name, rec ID, the body string, and this is a callback function. Okay, I know it's kind of funky, but there's a reason why we did this because the database calls are asynchronous. So we needed, when it's done, we need something, we need like a place to go back to. Okay? If you're writing actual real code, you wouldn't do it this way, but I wanted to try to get it all in one file and as simply as possible. Okay? So yeah, so that's a callback function. And here's the callback function here. It's going to set application JSON. Okay? It's going to just serialize the object, JSON.stringify, writes the header, and then writes whatever the output string is. So this is a pretty simple callback. Okay? So we're going to get an object. We're going to get a JavaScript object back from this REST function. Right? So this is the REST function that we're calling. Okay? And all it does is it's really, really simple. Also bad code, but it's simple. Checks to see if the table name is Sencha-con. If it's not, it says false, because I don't know what tables you're looking for. So it only supports that one table. And then if it's a post or a put, the body string converts it to an object. And then all these different methods are your REST methods. Okay? So on a get, if the rec ID is there, gets back one row, otherwise lists the table, post inserts, put updates, delete, deletes. Okay. So at this level, it's pretty simple. Okay. Any questions? All right, so I've just given you the code for a REST API server. And then let's just take a brief look at the database. It's not actually that much more. So a get, so this is kind of the syntax for SQLize. It just says, I'm going to get all the rows, and here's the where clause. And then whatever comes back, I'm just going to send it back. I'm going to send the object back, and send object response is in the data here. It says, I'm just going to send this back. What I'm going to do is I'm going to create an array of all the rows. I'm going to set this success and total thing, okay? Put everything in data, and then call the callback. The callback just sends it back to the client, okay? So that's the get. Insert, a little bit more complicated. Does insert object, okay? It does this funky thing where it just takes the ID and then just increments it by 1. If you have an auto-incrementing database, you don't have to do that, okay? But that's it. So I mean, the database code is not that interesting. You probably would write your own, okay? But you can see it's barely 100 lines, and so this is the back end, okay? So there's 100 lines here, and then there's 130 lines for the server, okay? Let's see it. Let's see this in operation, okay? Let me see. I have 20 minutes, okay? So let's see this. Let's see this running. Yeah. So I'm gonna refresh, okay? And then here are the rows. Actually, I need to make this a little bit narrower. Yeah, here we go. All right. So here are the rows. We're listing all the rows in the table. It's just some stupid rows. We can add, okay, let's see what happens. I'm going to refresh. And let's go into debugger, and let's see what's going on, okay? This options is like a core, it's like a cross, it's a CORS thing, like a cross, you know, it has to say, hey, you know, am I allowed to get data from the server? So don't worry about that. But this get is really where all the data is. So you can see here's the data that comes back, right? And this is what really this is the parsed version of this text right here, right? When we used it with curl, that's what came back, okay? So here, this is the same, okay? And this created at update at, that's put in by the SQLized by the ORM, so we don't use that, okay? But that's the data that comes back, okay? And then you've been at Sencha-con, so you would just create a model with those column names. So here's, you know, I wrote this in Architect, because, you know what, so I heard someone ask in one of the other sessions, you know, is Architect obsolete? When would I use Architect? So, you know, for this major bank that I'm writing, I mean, the code is crazy, right? I definitely don't use Architect. But it's great for prototyping. And for something like this, I mean, I know, I used to teach architects, so I kind of know it, but this took, less than 30 minutes to get like a full REST front end, okay? So if you learn it and you need stuff that's quickly prototypable, you can theme it in here and everything. I mean, I love it. You can crank out code very quickly, okay? So here's the model here, okay, and I'll show you the code for a model. It's really simple. I just take the JSON properties, right, and define fields for it, okay? And over here in the grid, we just define, whoops, okay. We just use we just use the data index and define the columns, okay? So not really any magic. So that's the list, okay? So let's say we want to add a row, right? So how does that work? Well, in the code on the add handler, I just create this fake record, okay? And I just add it into the store. And then it shows up in the grid. So this is here, and then you notice it increments the ID, right? I show you that code. So if you just keep adding rows, it'll just keep incrementing the ID. That's done on the back end. So let's take a look at what happens over the wire for that. So the verb for inserting, the REST verb for inserting rows is post, okay? So let's see what happens here. We send, this is it. This is the post data, right? We just send the JSON with our columns, and then on the other side, we serialize it and insert it into the database, okay? So that's the post, and you can see it happen a few times. Here's a post here, one post for each row that we inserted, okay? And then now, we don't want these things lying around, and let's see. Actually, I'm going to edit. You know what? I'll edit that later. So I'm going to delete these two rows. Okay, so let's take a look at what happens in the debugger. Okay, the delete verb is what deletes rows. Okay, and remember, this is the Sencha proxy. So this comes, you don't have to write any of this, right? This comes out of the box. Sencha proxy does all this work for you, okay? So what it does is it sends the, remember, it sends the table name, right? It sends the record ID that it wants deleted, but it also sends the object. Now, my code doesn't use the object, but if you need the object, it's actually in the body of the delete, okay? And then on the back end, I know the record ID. I just go ahead in the database and why don't we just take a look at that? It's easy. I go in the database. Here's the destroy. I get the record ID from the server, right? It's passed to me. And then I just delete it from the table. That's it. Okay. So, and then let's edit, let's see, let's edit something. Did you guys do anything at Sencha-Con? Just call out, I don't know. I'm kind of, let's see, what did I do?
Drink beer.
Drink beer, perfect. That's what I did. So drink beer, okay. And you'll notice, I mean, I'm sure, you guys all write code. So there's, you could auto-sync it, but I don't. There's this little red triangle that tells you that you have unsaved data. So then you click save, and it sends it down to the server. So let's see what happens here. So that is a put, right? Update is a put. And so it goes ahead, and it says, here's the table name. Okay, here's the record ID, and then I want to save this information in ID 6, priority 1, drink beer. Okay, and then that's in the table. And just to make sure that we saved it, I'm going to reload, and yeah, it was saved in the database. Okay, so let's see, did I cover everything? Insert, delete, update, get. Yes. Okay, so here. Maybe we should have a higher priority on beer. So priority 9, save. Okay. So let's see. That's pretty much it. Let me see if I forgot anything. Curl get post. Oh yeah, the network tab. I'm sure you. I mean, you guys are professionals. You know where the network tab in the Chrome debugger is. But in case you don't, that's where it is. That's where I was looking at all my network traffic. Yeah, that's it. Let's see how much time we got. 17. So we got a few minutes. And again, this is the GitHub repo for the server code. I'm going to put the client code up. I couldn't put it up before because I'm using a commercial version, and I didn't know they were still releasing the GPL, but they are. So you can still get the GPL version for open source stuff. So, any questions?
Can you look at the store?
Excuse me?
Can you look at the store?
Can you look at the store? You mean the code for the store? Sure. So the code for the store is, oh yeah, that's good. It's good to have. So yeah, the model, there's the model that we created, right? And the proxy, the URL, the proxy type is REST. The URL is, we have it, the table name in there. Okay, and then the ID property is ID. Root is data. That's like what the property of the array is. Okay. Any other questions? All right, was this useful?
Yes.
Was it okay? You could use Express.js, but now you kind of know what's happening, below, under the hood. Okay. Cool. Thank you.